All right, let's do it. That's right. So chapter 10, retake. That's what we're doing. So it says find the circumference of the circle. So here's the deal. Let's blow this up just a little bit so we can see a little bit better. And I think I might have enough room in here to write. Let's try a different color. Here we go. All right, so find this circumference. It says exact. The reason it says exact is I don't want decimal approximations. So if you look at this, how do you find the circumference of a circle?
You have to find the radius.
Right, you got to find the radius. So it's what? It's 2 pi r. That's the circumference of the circle. So you got to find the radius. So what we're going to do first of all is find the diameter, then we'll find the radius, then we'll plug it in here, and we got the circumference. Does that make sense? So we got to find that right there. But really, we're going to find this whole thing. Because look, I've got 16 and 12. It's a right triangle. I could use Pythagorean theorem, or watch. What goes into both of these? 4 does. 4 goes into this 3 times, 4 times, and what do you think? 3, 4, what? 5. 5 times what? 5 times 4. So this whole diameter is what? 20. Okay? Knowing 3, 4, 5 triangles. Isn't that a little easier than going through Pythagorean theorem? Yeah. So that's 20 right there. So what's the radius? It's 10. So the radius is 10. So it's 2 times pi times 10, which is what? 20 pi. Leave your answer like that. It says exact circumference. Right? And then that's how you should leave it. Let me get my answer key out. Make sure I'm getting this right. Now look, some of you guys, you know how I've been on this stuff. I'm too easy on you. Some people put this in a calculator, and I still gave it to them, even though it does say find the exact circumference. I couldn't be any more clear than that. On the final, I'll probably be as wimpy as I am on the regular test. All right. So if you actually put that into a calculator, but why bother putting it into a calculator, right? I mean, you're done right there. Don't take any more time or effort to put it into a calculator. You're finished. Go to the next problem. Yes. Just put it up here. All right. Let's do the same thing with this. So out of all the times we've talked about exact answers like that, have I convinced anybody that it's better to keep it like that than throwing it into a calculator? No? You guys were well trained then, because when you were a kid, there must have been a teacher that just forced you to not keep your answer like this or improper fractions and things like that. I tried to break you, but I don't know if I did or not. Let's do this one. I got 5 and 5. Now this is not one of those special, well, it actually is, isn't it? It's an isosceles triangle, isn't it? So which means it's a right triangle right here, so it's 45, 45, 90. What is the hypotenuse if I know one of the legs? So this would be what? Right, so the whole entire diameter would be 5 squared of 2. Agreed? What would the radius be then?
2.5.
It's half of it. Just do that. Why 2.5? Just do it like that. That's easier, don't you think? No? Still haven't convinced you, have I?
No.
You wouldn't rather have it like that?
No.
You'd rather have 2.5?
Yeah.
I wouldn't. Okay, so here we go. So let's do the circumference. Now watch, I'll show you why. You tell me after we're done this that you wouldn't rather have it like this. So circumference is 2 pi r, correct? All right. Or you could have just said what? Why are we doing the 2 pi r? You could just say what? Or pi times what? The diameter. We already know the diameter, don't we? So you might as well just use that. Why bother going 2 pi r? Yeah, it should stop me on that. I just did, for some reason, I just got stuck on finding the radius. But yeah, if you just know pi times diameter, that's the circumference. So look, it's pi times the diameter. What's the diameter? It's 5 squared of 2, isn't it? All right, and then pi, boom, that's it. You're done. Isn't that easy? All right. You probably could have done the same thing over here too, couldn't you? Instead of finding the radius, that was kind of silly. You already know the diameter, so you could have said pi times the diameter or just 20 pi, right? Pi diameter. So that would have been even a little easier than what I did. Still works. Okay, we good with that? All right, let's just a little smaller so I can see this whole thing. Make it a little smaller than that. All right, let's see what we got here. Find the degree measure of the arc if angle QRS. This angle right here is 50. I'll blow it up in a second. Ooh, that's terrible. And then SRT is 90. SRT is 90. And what am I looking for? I'm looking for arc XQ. So I'm looking for that arc right there. So let's blow this up a little bit so we can see it a little bit better. Ooh, my goodness, that's ugly. Tell you what. Boom. Okay, what did I say this was? 50?
50.
There we go. That's a little bit better. And this is a right angle. And we're just trying to solve for this arc right here. Agreed? Well, this is a central angle. This angle right here is a central angle. And you're like, well, why do I even care about that angle? Because whatever this angle is, that's what this arc right here is. XQ. Everybody see that? Because that's the arc that's formed by this angle right here. So if this is 50, what's this angle right here? 130, right. How'd you get 130? You want 180 minus 50. We've been doing that all year long, haven't we? That kind of stuff, finding that supplementary angle. So what's this arc right here? It's 130 degrees. That's all there is to it. That's easy, isn't it? Let's see what else they ask you. XQ VSX. Where is that? Let's blow this up a little bit more. And it's arc VSX. So it's from here, right? Let's do this different color. Let's go pinkish. Right? It's from here all the way around to there. I'll just try to sketch it around if I can. That's arc VSX. Agreed? So basically, what's the easiest thing to do? Do you want to add up all those angles in there? No. Just find this one and take it away from 360, right? So what is that? That's 50, isn't it? Well, you can just say it's 50 because it's a vertical angle with this angle right here, right? So that's 50. So how do I find this whole thing? Right. Not 180. Let's just go 360 minus 50, right? You can do that in your head. That's 310. There you go. That's the angle. We good with that? All right, look at this one, though. It says if XS, which is that diameter, isn't it? If XS is 20, find the length of arc XQ. All right, so let's blow this up again so I can see it. Tell you what, let's get rid of a bunch of this stuff. Get rid of all that. And I think we can get rid of that too. All right. So let's still write this. Sorry, I should have not erased those things. All right, so that's what we know right there. And what did it say again? It said, yeah, if XS is 20, so that means what? The radius is 10, okay, or the diameter is 20, however you want to do that. Find the length of arc XQ. So we want to find the length of that arc right there. Let's do that.
That was 130.
Okay. Yeah. Yeah, we found this earlier. Remember, this is 50, so that's 130, so that's 130. Yeah, we definitely need to know that. Yeah, that's right, because this is, remember, trying to find the length of it. We're not finding the whole length around the circle. The length around the whole entire circle would be the circumference, wouldn't it? Okay, so we're just trying to find the circumference of that arc, if you want to think of it that way. So we're not finding the whole entire circumference, we're just finding this little bit. So Demir said, let's go 130 over 360, and then what's it going to be? You could say 2 pi r, or you could say what? Pi d, right? We know what d is, right? Which is 20. And so you could do that. And you could put that on your calculator. And let's see, which number was that? 5, let me see. 22.7 approximately. It doesn't come out perfect. So it's approximately 22.7. All right, and that's a length, so it's not degrees, is it? It's how long it is. If I took a piece of string and wrapped it around from X to Q, then the length would be 22.7 if the diameter was 20. Make sense? Good. I take your silence as, yes, you have complete understanding of it. All right, let's look at this. That's probably not always the best thing to do, though, is it? Let's take a look at this thing. Find the measure of ON. So we're trying to find this right here. We'll just call it X. Is that all right? If OM is 3 and LN, that whole thing from there to there, is 8. All right. Let's make this a little bigger.
Oh no, it's 3 from 5.
Yeah, it is. Very good. Watch. If that whole thing. Now look. This is an isosceles triangle. If you draw perpendicular to the non-equal side, then what's it do? It, first of all, it bisects this angle and also bisects this side right here. Okay, so we've talked about that quite a bit before, haven't we? So if that whole thing is 8, then this is 4, and so you got what? 3, 4, what? 5, just like that, equals 5. Simple. Wasn't that fun? Yeah, I like it when they're that easy. We're rolling along, aren't we? Let's see what we got here. Okay, the quadrilateral is inscribed in the circle HGJ. Let's make this bigger. Is 3x minus 5. Where in the world is that? HGJ. This one right here is 3. What's that? No, HGJ. That's right. So it's 3x minus 5. That's what that angle is right there. And then IJG. Say that a bunch of times fast. IJG is what I say was 3x plus 5. Okay. So this is 3x plus 5. That's this angle right here. Now, there's a key to this. You got to understand what's true about opposite angles on an inscribed an inscribed quadrilateral. When it's inscribed in a circle, what's true about the opposite angles? They're 180, right? They're supplementary. Okay, they're not equal to each other. They're supplementary to each other. And what are we trying to find anyway? We're trying to find. Here's the problem. Right there, GHI. So let's do that in a different color. GHI. So we're trying to find this angle right here, aren't we? So really, we've got to find x, don't we? So if we find x, we can just put it in here, multiply by 3, and we got that angle. So how in the world are we going to do that? Well, look, these are opposite angles, aren't they? All right, and what do we say about the opposite angles of this inscribed quadrilateral? They add up to 180. So let's add them up and set them equal to 180. So I've got 3x plus 5 is one of them. What was the other one? 3x, right? Equals 180. So that's 6x equals what? 175. So x equals, I don't know, somebody do that for me. 29.2. Okay. And then you plug it in, you multiply that by 3. Yep. Make sure I'm doing this right. GHI, yep. 87.5. Right? Multiply this by 3 because we're going to find this angle. So GHI is 3 times this. Did I do that right or not?
That's right.
Does it come out to 0.5?
I got 0.6.
Yeah, it should be 0.6 because it's 3 and 2. But it's, what is it, 87.6? Okay. I don't know why I have 0.5 written. I think, don't know why. I'm trying to think. Why I have 0.5. Oh, I put 0.5 here, didn't I? According to this math, though, it's 0.6. Now, it would be the same thing. I mean, it's right either way. Make sure I'm doing this right. This plus this minus 175. Maybe that didn't... Did that come out exactly 0.2? What was it? That's probably why. What's 175 divided by 6? Do it real quick for me. Exact. Give me the whole thing. Ah, okay. That's probably what it was. And then I probably... Because watch. Yeah, if you divide this by 2. So watch this. This is why I got the 0.5. Because 6x equals 175. Watch this. If I want to find 3x, don't I? So if I wanted to, look, I could just divide by 2. Anybody think of that? So 3x equals 87.5. Wouldn't you agree with that? Okay, so 3x is 87.5, so that's what that is right there. So it's just 87.5. So that's how I got that. Just because if you would have used the whole calculator number for this, then multiplied it by 3, you would have gotten 87.5. Everybody good with that? All right, I just want to make sure why I got what I got. Okay, let's keep going. Let's find JGH. Don't worry about him. Let him do what he's going to do. I don't care. JGH. Let's find that one. That's this right here, right? That's this one.
No, it's the arc.
Oh, it's the arc. Oh, my bad. Yeah, arc JGH. So it's from here all the way to here, right? So it's from here to here. That's the arc. So how in the world do we find that arc? I don't even have a central angle or anything, but I do have an inscribed angle, don't I? See this angle I up here? Comes here, comes here. So if I find this, what is this arc to this angle? It's double, exactly right. So let's find this angle right here. Well, I already know what 3x is. It's what? It's 87.5, right? Subtract 5 from it, which would be what? 82.5. right? So that angle right there is 82.5. How do I find this one right here?
Subtract it from 180.
That's right, subtract it from 180. So 180 minus 82.5. Give me a number for that. 97.5, my favorite radio station. I don't know, it just sounds like a radio station. I have no idea. So it's 97.5 right there. So what do I do to find this big old arc? Times it by 2. Do that for me. Multiply that by 2. Hopefully you get 195, do you?
Yep.
Good. Alright, so that's that arc. So this big old arc right here, what letter is that? J? J, G, H. That arc is 195 degrees. Okay. Yeah. Is it a radio station? Is it that Ben station, or I just heard it? Oh, the Fanatic, of course. No wonder it popped in my head. Yeah, because I listen to that all the time. Mike Missinelli. Anybody listen to Mike Missinelli? See, now that's another thing. I don't want to get started again on this, but let me just say this. I'm not putting you down or anything. I'm just saying. See, if you're a hometown fan like I am, just listen. Just listen. Just listen. This is my last chance to teach you something important, and that's about being a real fan. See, the one thing, if you're a Dallas fan or if you're an Indianapolis fan or something like that, you don't get to listen to the hometown talk radio and talking about it, and that's what I love. I love after a game, if they win, I like hearing people talking about how great the team is, and if they lose, I love hearing people talk about how stinking the team is and all that kind of stuff. Yeah, but it's not local. It's not local. You don't know what you're missing. That's all I'm going to say. I'm not going to say that you can't like those teams. I'm just saying you just don't know what you're missing. All right. There. I put that out there on YouTube, for the world to hear. Hear the truth. Hear the truth. Here we go. Let's do this. Any line that looks tangent to the circle is tangent to the circle, we'll say. AP is 10. I'll tell you what, let's make this bigger. And I've got all those numbers in front of me, so I'll just put them in here. AP is 10. It was actually easier than it looks. It looks real confusing, doesn't it? But you're right, it is a little easier. BQ, what is it? 7. All right. And then CPE is 45. CPE right there is 45 degrees. And that's all they tell you, right? So the first thing they ask you is find CG. Now look, if this angle is 45 degrees, tell me something about the angle that's formed here between a radius and a tangent. It's perpendicular. It's 90 degrees, okay? Yes? 40 of them. I'm not going to tell you which ones. That's all right. Know how to do them all. All right, so you got to... All right, so here we go. So you got to find CG, this thing right here. So look, if this is 45, then what? Then that's 45. If it's 45, 40... Just hang on. If it's 45, 45, what's true about these two? They're equal to each other. And look, what's PC? They don't tell you PC, but it's a radius, isn't it? And PA is a radius, so that's 10. So what's CG? So that's 10. So that's one of the things you had to find was CG. The other thing you had to find was FQD. Where is that? FQD, this little angle right here. I'll tell you what, let's do that in a different color. Okay, just give me a second. I'm just changing my colors. I'm not going to use yellow. I'll use this blue, this darker blue. All right, so look. Is that better? Can you see everything in there? I think I'm all inside the... All right, so yeah, look at this. If this is 45, watch, that's 45. This is also right, isn't it? Right, because it's a radius to a tangent. And so if this is 45, this has to be 45. All right, so that's one of the other angles you had to find was that right there. DG. That's right. All these lengths are exactly the same. So this length and this length are the same because it's 45, 45, 90. And you say, well, how do I know what that is? Because I don't know what that is. But that's a radius. Look, that's a radius. That's 7. So that's 7. So that's 7. Everybody got that? So that's another thing you had to find. And one more, right? Arc DF. Where's DF? Where's D? Right, this thing right here. Okay, let's do that in a different color. Let's go orange. Yeah, that's right. See, it looked complicated, but really it wasn't that hard at all. See this arc right here? It's equal to the central angle. If that's 45 degrees, then that arc right there is 45 degrees, and there's all the stuff that they asked you to find. Yeah, we did pretty good, didn't we? I tell you what, let me save the rest for the other class. We only have 5 minutes left. So I'll finish the rest of them in the other class. And we may, I don't know, we may possibly start on 12. 12? No, 11. We may start on 11 in the other class. Just depends on how much time we have. All right. Now, if you wouldn't have had locker cleanout day, we might have been able to finish this whole test. All right, so that's it. So this will be on YouTube very soon. So check it and study it. Tomorrow is the final.